Hello friends, so this video is for high school students, those who are doing high school. I mean they are in year 7 to year 10, and in mathematics they go through with different topics, different concepts, and it happens at times that we try to find a way to solve mathematical problems and we overlook the philosophical insights behind those topics. There are very important concepts which are expressed in mathematical equations which we do not understand. The depth of those equations we do not understand. And it is very important at times for us to look deep into those concepts so that we know what we are talking about. Is it relevant to the world we see around us, or is it just like finding the value of x, right? So what I'm going to do in this discussion is to present you some perspective of some familiar concepts which you are already doing in your mathematics in your school curriculum, and those topics are interesting. The concept which I will be dealing here is the philosophy behind arriving at an equation for a geometric figure. So you may have a geometric figure. It could be a straight line, it could be a point, it could be a triangle or a rectangle or any random curve. The beauty of mathematical reasoning or mathematics is that whatever shape you see or you can think of, you can express that shape in some sort of mathematical equation. And this is the thought you should be inquiring, like how it is possible. So what is the basic first geometric figure you can think of? You may think it's a straight line, but before a straight line we discuss something which is called a point like a dot on the piece of paper. So point is also a geometric figure which has got no length, no width, no height, and it's just a point. Now if I ask you a question that I want to express this point with a mathematical function, is it possible? Think out of the box, a little bit deep. You want to express the geometric figure which is a point. You want to express this point in terms of a mathematical function. Now before we think of a mathematical function, we think of something which is called a reference frame, right? So everything we deal with in mathematics or in science is from a certain reference frame. A reference frame is nothing but a point of view of an observer, right? In mathematics, this reference frame is represented using a Cartesian coordinate system or a coordinate system in general, we say. We all know that we have got x-axis and y-axis, right? So the x-axis which extends towards east is called the positive x-axis, and the one which extends towards west is called the negative x-axis. Similarly, you have got y-axis, which is positive y-axis pointing to north and negative y-axis pointing to south. So this is a two-dimensional Cartesian coordinate system. Now if I have to find a function, mathematical function, to denote the point, I can use this reference frame, this coordinate system, in finding the value of x and y to locate this point in this two-dimensional plane. Now, this very idea of denoting the point with its coordinate gives a mathematical function. In general term, in computer graphics, we call it a pixel, right? So you can draw x and y axis, draw a point, and then you can find the relative distance of this point from x axis and y axis. That is your mathematical function. You may argue that no, the mathematical function is something fancy like y equals to fx. So y, which is a dependent variable, is dependent on x with a function f, and the function f is nothing but the property of that geometric figure. That's true, but we are dealing with point, right? A point is having no dimension. So if the point is a geometric figure which has got no dimension, what is left is the coordinate points relative to the reference frame, right? So on my drawing board, if I have to draw, I will just show you what I am talking about is that you have got a line, you have got another line which is intersecting at 90 degrees. This is very familiar, you all know what is this. This is a two-dimensional coordinate plane, this is called x, this is negative x axis, this is y axis and negative y axis, and then I asked you to imagine a point P which will have a coordinate x and y. Now this P is going to have some relative distance from y axis and some relative distance from x axis, right. So this position P is a function of x and y, where x is the horizontal component, y is the vertical component. So this is how we represent a point in a mathematical form. So if I have to represent a point in a mathematical form, I can't do this in vacuum. I need some reference frame, and this is the very important point. This is the point which I am trying to make you aware of, that whatever equation we see in mathematics, this equation is always in reference to some reference frame or some statements or some premise we say in philosophy. Now, what is the next important geometric figure? You can say that, oh, I forgot to record my drawing board. Now I am recording the drawing board. So the next geometric figure you can think of is a straight line, right? Now let's do the same exercise for a straight line. Let me take this whole figure, copy. So this is the famous Cartesian coordinate system which you see here. I'm just removing the lines. Negative y. Now if I have to draw a line, let's take a color red. I can draw a line in any direction, but for the sake of simplicity and for the sake of continuity which we see in our school textbook, I am taking a very familiar way of drawing the straight line, and that is as I am showing here. So this is the straight line. If you see my drawing board, this red color line is a straight line. Am I correct in making that a statement? This line is not a straight line. This is something which is called line segment. So as you see here, I have a Cartesian coordinate system which is x and y axis. You see here on my drawing board, which is in green color, and then I have a geometric figure which is a straight line. Actually, I am wrong in saying a straight line. This is a line segment, because if you remember, a straight line is something which is a straight with arrow on both the sides, so that it can extend up to infinity in both the directions. What I have done is I have taken a segment from this line and just draw it on the two-dimensional plane. Now, the purpose for my drawing is to give you an understanding of how we deduce or how we form a mathematical equation to represent this straight line in some constant and variables and with some properties which this line is having. Now, if you do not know anything about a straight line or an equation for a straight line, you can think from the start, think from the scratch, that how we can represent this straight line with an equation which will reflect its properties. Now, what I will do here is I will select a point P, and we know that the property of this point P is represented with the values x and y. We have already done in defining the equation of a point, which is something which is outrageous if you think of how we can make an equation of a point. But we tried, and we know that the equation of a point is nothing but the coordinates of the point x and y. Now, if this is P, x and y, we can think of two properties of this straight line. One is that this line segment or a straight line, I am using line segment and a straight line interchangeably here, and I will say straight line, but this is a line segment. Now, it has got infinite number of points on the line, many points, and every point will have a coordinate. But these coordinate values are not random values. These values are restricted by the way this line is positioned in the two-dimensional plane, right? So, this line is extending from one side to another side, and this extension has got a property which we can quantize, or we can fix with some value, right? In mathematics, having a situation like this where you have to deal with some value and some direction is indicating towards a special mathematical operation which is called geometric operations, which is also called the vector operations, right? Now, I am not dealing with vector here, but what I will do here is to represent the property of this line relative to the reference frame. I will say that let us consider the angle it makes with the axis. Let us say the angle is theta, right? Now, this angle is constant. If you see here, this angle is constant with respect to x axis. If you know basic geometry, you know that the angle, the elevation with x axis is a constant value. Now, what you will do here, you can take any angle, either angle made by x axis or angle made by y axis, but for the sake of simplicity and continuity, as is in your school textbook, I will take this angle theta. If you wish, you can do the same exercise with the angle alpha, which is made with y axis. You can say alpha or beta, whatever you want. Now, here if you find the relative distance between the axis you will see here that you have got this length as x and this length as y. Now, with this angle theta, there is another important constant which you have is the length which is intercepted by this line on the axis. Let's call this length as c, right? So this length is c. Let's draw this line as well. So if you have this point P, this point Q, this point R, P, Q, R, then what you will see here is QR is x and this length PR, if you see the total length is y and you have got an intercept c, so this will be y minus c, right. So you have got x, y and c, these are the three terms, x and y are the coordinates of the point and c is another constant which shows one of the property of the line relative to the reference frame, that it is intercepting at some point q and this length is c, right. So now we are on our way to form an equation. What we can do here is we can say that we can do many things here, but one of the things which I will do here is to find the relationship between this x, y and c, and one way to find the relationship is to consider this angle theta, and you know that if this angle is theta here, then the same angle is going to be here theta, right. And since you know this in this angle PQR, this is a right angle triangle, by the way. In this triangle, you know the two sides which are the side opposite to the angle and with the angle which is perpendicular and base. You can write an equation for the tan. So tan theta here will be PR upon QR. And what is PR is y minus c. What is QR, which is x. Now what you can say here is y minus c equals to x tan theta. When I write tan theta, I have to write tan theta. So instead you can say here that tan theta is m, you can write mx. Now you can write y equals to m times x plus c. If you look into this equation, what you see here is that this equation uniquely represent what this straight line is. You have got a relationship between different points on this line, which are many points, infinite points on the straight line, and the way they change the value is in according to the angle it makes with the x-axis. And the calculation of angle, we have taken here the value of tan theta. We could have taken sin theta and cos theta as well, but it's more practical and more easy to use tan theta. You can write tan theta equals to sin theta upon cos theta and make this equation in terms of sin and cos, and then you can use another formula is like sin square theta plus cos square theta is equal to 1 and represent this equation entirely in terms of sin theta or cos theta. But in our mathematical discourse, the way mathematicians talk, the way it is taught in your school and it's written in your textbook is with tan theta. So my advice is get yourself familiar with what is there in your textbook first, and then think deeply, think left and right, and try to do more mathematical stunt if you wish to. So this is the way we write an equation for a straight line. Similarly, we can write equation for a triangle or a square or a circle or a parabola, hyperbola, and to the extent equation for a random curve, which you will not be doing in your school, high school. But if you go for advanced mathematics in engineering, you will learn something which is called Fourier series, where you express any random curve as a series of sine and cos. So that's all about forming an equation for a geometric figure in this video. I hope you like this video and you like the unique insight which I have presented here. In schools, you will be given this equation y equals to mx plus c and solve the equation, and you will be knowing the different way of dealing with different type of problems in finding answers. But it's also very useful and interesting if you develop your insight into behind the scene stuff which is happening in mathematics. You can't see y equals to mx plus c straight away in nature like in an empirical way. It's a philosophical construct in your mind, and this gives rise to understanding different things. The formation of this coordinate system x and y and the way we represent mathematically different geometric figure is the foundation where we have done our advancement in computer graphics. Thanks for watching the video. I hope best of luck for your school examinations.